Not through air, not through space, through reality itself. Falling toward the edge of everything that makes sense. The event horizon, the line between what is known and what must never be known. A black hole. For over a century, it has loomed as the final question mark in physics. A place where time stops, space folds in on itself, and the known laws of nature get shredded like paper in a storm. General relativity told us this is a singularity, an infinitely dense point at the center of a collapsing star, where gravity becomes so intense that not even light can escape. A cosmic dead end. The ultimate destroyer, a region of space-time from which nothing returns. Except now, maybe, everything does. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now, and be part of the few who never stop searching. Michio Kaku, theoretical physicist and co-founder of string field theory, has stepped into the chaos with a proposal that changes everything. Not just the nature of black holes, but the foundations of physics itself. What lies at the heart of these monsters isn't a singularity. It isn't a point of infinite density. It's something far stranger, a fuzzball, a seething tangled web of strings, the basic building blocks of the universe. It sounds absurd until it doesn't sit. Because the old model was breaking, cracking, under the weight of paradox. Hawking's radiation told us that black holes evaporate over time. But if they evaporate, where does the information go? If information is truly lost, obliterated in the black hole's core, then the rules of quantum mechanics collapse. And that's not a small thing. It would mean that the universe is not predictable, that cause and effect unravel, that the past can simply vanish. Physicists have wrestled with this contradiction for decades. Stephen Hawking called it the black hole information paradox, and for years no one had a solution that satisfied both quantum theory and general relativity. Until now, Kaku and his colleagues pulled from string theory, the idea that all particles are just vibrating strands of energy, dancing through multiple dimensions. In this model, a black hole doesn't collapse into a point. It gets replaced by a ball of strings, what they call a fuzzball. There is no singularity. There is no point of infinite curvature. The matter that falls in doesn't vanish. It gets woven into the fuzz. That sits the breakthrough. Because it means information isn't lost. It's stored. Imagine a star dying. Its core collapses, and a black hole is born. But instead of collapsing into a point, all the quantum information of that star, every atom, every photon, every ripple of energy, is absorbed into this quantum fuzz. It doesn't disappear. It transforms. Kaku's theory makes black holes into something we never imagined. Cosmic libraries. Not destroyers, but archivists, keeping a record of everything they've consumed, every galaxy they've grazed, every solar system they've devoured. These aren't voids. They're vaults. It redefines death in the universe. Because when a star dies in this model, something of it remains, encoded in the tangled quantum threads of the fuzzball. Still there, just different. And if information is preserved, then in principle, it can be retrieved. You heard that right. In theory, however impossibly, the blueprint of anything swallowed by a black hole could be reconstructed, including people, including planets, including civilizations. The memories of the universe may not be lost. They may simply be waiting. It stakes a staggering shift in perspective. And it's not just theory anymore, because for the first time in human history, we've started to see black holes. The Event Horizon Telescope captured that now iconic photograph of a black hole in 2019, revealing the shadow of the abyss. Gravitational wave detectors like LIGO and Virgo have recorded the ripples of colliding black holes echoing through space-time, and the data doesn't quite fit the traditional model. There are discrepancies, deviations, strange patterns in the waves, echoes that shouldn't exist unless something more complex is happening at the edge of the void. Some physicists believe we're already seeing evidence of fuzzball behavior, that the signals we detect don't match the clean, predictable curves of classical black holes. They hint at internal structure, at chaos, at complexity. It sits early, but it sits real. And if it sits real, it changes everything. Because suddenly, black holes aren't just places of death, they're potential gateways. Not just to knowledge, but to new frontiers. Fuzzballs aren't smooth. They're rough, dynamic. They oscillate and pulse. In string theory, they may extend across multiple dimensions, touching parts of the universe we can't even perceive. And if that's true, then black holes might not just be ends, they might be connections. Portals, tunnels through the quantum foam to other universes, other timelines. The implications are terrifying and beautiful. Kaku doesn't just hint at time travel. He lays out the groundwork. If fuzzballs are governed by quantum rules, then entanglement, the spooky connection between particles separated by vast distances, could apply at black hole scales, and if entanglement can link across space-time, then cause and effect might blur. Time might not flow as we think. The past and the future might be connected in ways we don't understand. It sounds like science fiction, but the math checks out. Because what this theory suggests is that the universe isn't a machine grinding forward toward entropy and oblivion. It's a memory. A self-recording organism. Every event, every collapse, every tragedy and triumph, stored, preserved, embedded into the quantum foam of existence. Even in death, something remains. A civilization vanishes, but its record is encoded in the fuzzball of the black hole it created. Kaku calls it the ultimate union of physics, quantum mechanics, and general relativity. Two theories at war for a century, finally reconciled in the heart of the most violent object in the universe. Not with destruction, but with complexity. Not with chaos, but with structure. And it doesn't dead end there. Because if black holes are made of strings, and strings make up everything, then the universe itself might be one giant fuzzball. A massive entanglement of information loops and vibrating energy. We might be living inside a black hole. The Big Bang might not have been the beginning of time, but the interior of a collapsing star from another universe. One fuzzball birthing another, a cycle of information transfer across dimensions. This isn't just physics, this is metaphysics, cosmology, theology. The idea that death is not the end but the transformation. That knowledge is never truly lost. That somewhere, in the tangled threads of space-time, the echo of everything remains. Even us. The image of the black hole, once a symbol of annihilation, is now something else, a question mark still. Yes, but also a mirror. Because in trying to peer into its depths, we are really peering into the nature of reality, the nature of ourselves. And what we're finding is that the universe may be far more resilient, far more interconnected, and far more bizarre than we ever dared believe. Michio Kaku's fuzzball isn't just a theoretical solution. It's a new lens, a new story, one where information doesn't die, where reality is woven, not broken, and where the deepest, darkest places in the cosmos may be the very keys to understanding it. So when you look up at the night sky and see the darkness between the stars, you know this. That darkness is not empty. It is full of echoes, full of memory, full of meaning. Black holes are not the end. They are the archives, and the implications spiral far beyond black holes themselves. Because if Kaku is right, if the fuzzball model reflects reality, then we are living in a universe where the foundation isn't built on destruction, but on transformation and preservation. And this shifts the paradigm, not just for physics, but for everything we think we know about time, causality, and existence itself. The fuzzball theory turns our greatest fear, the erasure of information, into its opposite. In this framework, information is never lost. It's encoded, embedded, scattered across a tangled web of quantum strings, which means history isn't erased. It's conserved. Memory isn't destroyed. It's stored. The entire life cycle of a star, the chemistry of its planets, the biological signatures of life that may have arisen in orbit, it all goes in, and none of it is annihilated. It's rewritten, yes, transformed, absolutely, but still present, still traceable, still meaningful in the quantum configuration of the black hole's internal structure. This directly challenges the most haunting consequence of Hawking's earlier work, the idea that black holes eventually evaporate, that they emit radiation and slowly die, taking all the information they ever consumed with them into oblivion. If that were true, it would tear a hole in quantum theory. It would violate the principle of unitarity, that the future of a quantum system can always be predicted from its past. But the fuzzball theory restores unitarity. It restores order to chaos, and not through convenient speculation, but through mathematical rigor, grounded in the deepest layers of string theory. Kaku's team posits that each fuzzball configuration corresponds to a possible microstate of the black hole, and the enormous number of such microstates accounts for the entropy of the black hole. In other words, the complexity of the fuzzball's internal structure is what encodes its thermal properties, its entropy, its temperature, its radiation profile. This explains why no two black holes are exactly alike, because their internal fuzzball states differ based on the specific configurations of the matter and energy that went into their formation. Two black holes of the same mass may still hold entirely different quantum signatures, because the stars that created them, the environments in which they formed, the particles they absorbed, all of it creates a different fuzzball structure. This also redefines the event horizon itself. In classical theory, the event horizon is a one-way surface. Nothing escapes, nothing transmits outward. But in the fuzzball model, the event horizon isn't a smooth boundary. It's a chaotic, dynamic region that reflects, emits, and encodes. The surface of the fuzzball radiates subtle quantum information outward, not as classical matter, but as delicate quantum vibrations. This might be the source of Hawking radiation itself, not a feature of space-time curvature, but the quantum echo of a fuzzball's surface dynamics. This opens up avenues for experimental verification. Gravitational wave observatories are already pushing the envelope, detecting the ripples of space-time created by merging black holes. And some of those signals exhibit properties inconsistent with the classical singularity model, such as delayed echoes, subtle frequency modulations, and interference patterns. These could be the fingerprints of fuzzballs. Not proof, not yet, but hints. The same goes for the Event Horizon Telescope and its successors. The blurry ring of light surrounding the black hole in M87 or Sagittarius A** might contain substructures, deviations from circular symmetry, polarization anomalies, temporal flickering, that point to a complex internal structure. The more we refine our instruments, the more these deviations may emerge. And if they do, they could validate Kaku's model and force a rewrite of physics textbooks worldwide. But the implications stretch even further. Because if information can be preserved in the fuzzball, then theoretically, information can be retrieved. Not by us, not with current technology, maybe not ever with any technology we can build. But the point is that the information is still there, which leads to an uncomfortable but exhilarating question. What if some advanced intelligence, not bound by our technological limits, could read that information? What if, buried inside a black hole, are the preserved blueprints of ancient stars, lost planets, forgotten civilizations? What if, for some unimaginable observer, black holes are not opaque, but transparent, not barriers, but windows? That changes the function of black holes in cosmic evolution. They're no longer passive endpoints. They become active memory banks, repositories of experience, mechanisms by which the universe keeps a record of itself, not for us, not necessarily for any purpose, but simply because that is the nature of reality, to conserve, to encode, to remember. And it also casts new light on the early universe. If black holes are fuzzballs, and if fuzzballs are dense regions of vibrating strings, then maybe the Big Bang wasn't a singular beginning at all. Maybe our universe was born from the collapse of another. Maybe the Big Bang was the internal experience of a fuzzball in another dimension, a universe within a black hole. This isn't science fiction, this is emerging theory, a cosmological model where black holes birth new universes, and those universes in turn create their own black holes. A cycle of memory, collapse and rebirth endlessly propagating through the multiverse. And if that's true, then time itself becomes fluid. Linear causality gives way to entangled histories. The future is no longer just the unfolding of the present. but a reflection of all the quantum interactions encoded in the fabric of space. In this model, everything is connected. The death of a star, 1 billion years ago, leaves a fingerprint on the fabric of reality that still ripples into our present, not metaphorically, literally. The entire structure of the cosmos is a superposition of past events entangled through quantum fields and gravitational feedback. And black holes, these fuzzballs, are the knots in that web, anchors of memory, nodes of meaning. Even consciousness starts to feel fragile in the face of such a reality. Because if the universe is conserving information at every level, if nothing is lost, if every interaction leaves a trace, then what is identity? What is mind? Are we too just emergent patterns in the cosmic memory field, temporarily coherent, ultimately entangled? It's a philosophical bombshell, not because it reduces us to particles, but because it elevates particles to something more. Every atom in your body may have once been part of another world. Every photon that touches your skin might carry with it the history of stars that burned before Earth existed. And if those photons ever fall into a black hole, their stories won't end. They'll be absorbed, transformed, encoded, added to the archive. Kaku's fuzzball theory does not just revise black hole physics, it reshapes our understanding of existence. And it dares to say something no other theory has said with such boldness, that the universe remembers that even in its most violent, terrifying processes, it is still engaged in an act of preservation, that black holes are not the end. They are the beginning of a deeper kind of order, an order we are only just beginning to glimpse. So imagine now that you're standing near the edge of one, not falling anymore, just watching, observing the dark sphere, suspended in the vacuum of space, ringed by fire and frozen time. For centuries it was thought to be the destroyer, the eater of worlds, the void from which nothing returns. But now, maybe, it is something else. A recorder, a messenger, a witness, and buried within its tangled mass of quantum strings are the blueprints of all it has consumed. The whispers of stars, the shadows of dreams, the silent imprint of every force that shaped it. Maybe this is what the universe has been trying to tell us all along. That the void is not empty, that the silence is not silence, that even in the coldest, darkest places, something remains. And that in the heart of the black hole, hidden within the fuzz, vibrating through the threads of space and time, is the story of everything. This story isn't finished. It never will be. Because in the universe Kaku envisions, no ending is final. No collapse is absolute. Every action, every particle interaction, every fusion event in the core of a dying star becomes part of a vast unfolding memory, a network of information with no delete key. Black holes in the fuzzball model are not tombstones, they're time capsules. They do not erase, they preserve, albeit in forms we can't yet comprehend. And that forces us to rethink what it means to observe, to measure, to understand. Physics is no longer the science of prediction. It becomes the study of memory, of retrieval, of decoding the tangled script the cosmos has written into itself. And if we someday unlock even a fraction of that script, we might not just learn what lies at the center of a black hole, we might rediscover the lost chapters of creation itself. Not myths, but quantum signatures. Not metaphors, but mathematics. In Kaku's vision, black holes are the hidden servers of reality, storing the truth of everything, forever. And if we are clever enough, bold enough, perhaps someday, the universe will let us read its archive, one string at a time.